Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all on the second day of online course on optimum use of analytical and preparative HPLC. Yesterday was really amazing sessions. That was two sessions that was delivered by Dr. Shakil Ahmed and Dr. Jinhua. And today, Dr. Jinhua is also with us and he's online. So if any of you has any question, please write in the chat box anytime and he will be very happy to answer. And the first lecture today is again by Dr. Shakil Ahmed, who is a very renowned chemist and very much experienced in the use of HPLCs. And today his topic is optimum use of analytical HPLC. The second lecture will be by Dr. Yan, and she will be discussing about the preparative HPLCs. So the concluding session today will be at 2:05, so a bit earlier because there are some time limitations and I would not waste more time. So I would request Dr. Shakil to please start his presentation.
Bismillahirrahmanirrahim. Good afternoon, ladies and gentlemen. Yesterday we discussed about the analytical HPLC and introduction of the chromatography as well as the solvent system, solvents which we are using in analytical HPLC. And also we discuss about the detector, because detector is the eye for in the analytical chemistry, which can be show you the peaks which in HPLC. Okay, I just started with the presentation which yesterday I left. Can you start my presentation? Okay. Okay. Can you go to the last slide, which I showed yesterday? I think so. It's 38 number. Okay, this one, which I discuss all the detector along with. Okay, next slide. Next. Okay, now the integrator or data processing unit, which we are using for this purpose, we are using a computer, and in this data processing unit, the computer is give us the result or in form of the peak. Where's the pointer? Okay. if these kind of peaks are normally appear on a computer screen when you are involved in the analysis of any analytes on analytical HPLC. There is a several terms used here as a peak asymmetry, column efficiency. Always when we see the peak on a computer screen or in a print form, we always half of the peak. The retention time always shown in the half of the peak. So this is the width of the peak, and this is the height of the peak. So, and then you can see there is a W half, and peak width at half height. This is the half height of peak at the half height. This term are using. This is the point where we inject our sample or standard or the substance which need to be analyzed by the HPLC. This is donated by the. This is started from this place to. Unretained peaks are, you can see here, unretained peak. And these two peaks, you can see in the help of these peaks, we can calculate the peak asymmetry and the column efficiency by using this equation. Several terms used when we are using analytical HPLC. If you have a chromatogram of HPLC, you can see the peak width, and sometimes peaks are fronting. Somebody using the terms peak fronting. Sometimes you can see there is a several things, and it is donated as a peak tailing. And this peak is shown there is a no resolution, means poor separation of the two components. This is the baseline drift. So these kind of terms used in analytical HPLC when you have a chromatogram and you seen the peak shape by physical. You can see on the basis of, with the help of these kind of the shape, you can see this is a peak fronting, peak tailing, poor resolution, and sometimes noise. Okay, separation factor is the ratio of partition coefficient of the two components to be separate. So if you have a two component, then you can calculate the separation factor. This separation factor is denoted by this TR1 and TR2 is retention time of compound 1 and compound 2, and the peak height of the compound, peak height, compound 1 and compound 2. So unretained component is designed by TM. You can design here TM. Separation factor is also terms used, devil volume, hold up time, hold up volume. These all terms are using in analytical HPLC during the analysis when you are analyzing the using the gradient delay. Volume is volume between the point in which the elements meet to the top of the column. So this formula is using for hold up volume. The definition: the volume mobile phase required for addition of unretained component. It may be calculated from the hold up time at the flow rate. Again, this is more important to learn. If very good separation, the peak always symmetrical. If the separation is not good, when you half of the peak and calculate the area, by the formula. You can calculate the efficiency of the column, and there is a also very important terms used, the theoretical plates. Theoretical plate is the normally we are using this word for efficiency of the column. If the column is more efficient, theoretical plate is good, then we can see, okay, our separation is good, and we can calculate by the equation of shown here. Theoretical plate is imaginary hypothetical unit of the column, where these all terms, if you are involved in to learn analytical HPLC, this is a very important terms using in analytical field that called theoretical plates. In a function of unit of the column, again, this is the efficiency of the column. Okay. This is the formula we can use for calculation of the theoretical plate. And you just, if you have any question about this, you can ask during the presentation here. Okay, peak resolution is also very important terms using in analytical HPLC. So this is the formula which we are using for peak resolution, which on a previous slide I showed. There is a two peak retention time of peak 1, retention time of peak 2, with width or peak area of 1 and peak area of 2. Then we can calculate the retention peak resolutions. Asymmetry factor, which already discussed, if we half and draw the tangent in center of the peak, and first half and second half is, if it is same, means the column is very efficient. If there is a minor difference, which is also allowable with 5% plus minus, like this factor, you can calculate the asymmetric factor. Asymmetric factor is important for the column, because column is the heart of HPLC. If any kind of the analysis is depend on the nature of the column and nature of the component. Retention time, which already knows that retention time is the time when the peak is retained into the column. Retention volume is the volume utilized for retention to appearing the half of the peak. In chromatography, different peak correspond to the different component of the separate mixture. Retention time is the difference in time between the point of injection and appearance of the peak mixture. It is also defined a time required for 50%. Again, I'm insisting that 50% is means the 50% of the peak, not 50% of the analysis. It's a component to elute from the column. It is measured in minutes or seconds. The retention time is longer when the solute has high affinity to the stationary phase due to its chemical nature. Then again, K factor, dead volume, these all terms we are using this now analytical HPLC. Okay, separation factor is selective, or separation factor alpha is the ability of the chromatography system to chemically distinguish between the sample components. It is usually measured as a ratio of the retention capacity factor of the two peaks. One peak cannot help to calculate all these type of terms which we are using here. Always with the help of two peaks. One may be your sample, your standard, one may be internal standard we can use with the help of the sample, or standard and the internal standard we can calculate the separation factor, theoretical plates and so on. Again, this troubleshooting you can face during the analysis. This is the ghost peak. Ghost peak is when you are involved in analytical analysis, some kind of analysis. At first run, some peaks are appear, but in second run the peaks will not appear, and third run peak again not appear, means the first run has some leftover from the previous analysis. So it's called the ghost peaks. And ghost peaks also appear due to some air bubble in mobile phase, in detector, in many other things. This just for your learning. There is some kind of peak, have a different shape and use different terms. See here, flattening, no resolution, sometimes again no resolution. When we are using this kind of phenomena, facing means some maybe we use more compound we loaded on a column and more than the capacity. Maybe the wrong mobile phase, maybe the column is deteriorated. There is several things happen. So it's your practice. When you have a practice on it, you can observe this kind of peak with correlation. The baseline spike occurred due to the air bubble, which I already mentioned, detector, mobile phase, and many things. The thing is, air bubble. You can see when air bubble in the detector, very sharp peak and very thin peaks will appear, and continuously the difference is that air bubble peak is not reproduced at the same place. Retention time is not fixed, so it varies. So in this way, we can observe this. There is something happen in it. For example, one compound. If we have this kind of compound, how we can analyze, how we can see the analysis of this compound through HPLC, through HPLC with UV detector, HPLC with mass detector is a different approach when we are approaching on analysis. So we, if we have a known compound and we are following some pharmacopoeial method or analytical method or published method, we establish or we fix all the parameters according to the provided data. If we don't have a known sample, then we have some tricks used to determine. So the trick is, I have some videos here to see how we are working on analytical machine. Here I'm showing the Waters HPLC. Now we are starting the practical demonstration of analytical HPLC. This is my team. They are all my co-workers, and we are involved in so my aim is for you how function of the HPLC software system. So, in this presentation, we are going to demonstrate what is HPLC. One by one, we are going to explain the parts. Yes, explain how to make methods. But now we are studying the HPLC with the parts which we yesterday mentioned in our presentation. If you see, this is the integrator or computer. It is involved in data collection, which is generated by this hardware system. Okay, yesterday, as I mentioned, the theoretical aspects of the HPLC, and now this is the simplest HPLC system having only one detector. This is
analytical testing of HPLC. So my aim is for you how to learn analytical HPLC. The practical demonstration you already seen in yesterday, but today is more practical. How if you have this video and you have a water's HPLC, because there is a many kind of HPLC, but the basic function of the HPLC software is same. So we try for this presentation, we are going to demonstrate the water's HPLC. One by one, we are explaining the parts. Yes, one component is my other co-worker, Dr. Sabha, will explain how to make the methods, but now we are starting the HPLC with the parts which yesterday we mentioned in our presentation. If you can see, this is the integrator or computer. It is involved in data collection, which is generated by this hardware system. Okay, yesterday, as I mentioned, the theoretical aspects of the HPLC, and now this is the simplest HPLC system having only one detector. This is UV detector. This is column open. This is some sample compartment. This part is bound. Machine is offline. We are not started yet. But before starting, I just want to explain the hardware of the analytical HPLC. This is the sample reservoirs where we keep the mobile phase. And before starting, maybe my colleague can ask any question regarding the analytical HPLC.
Sir, please explain what type of detector it is. Is it only UV detector, or it can work on far beyond the UV?
No, this is UV detector. Actually, there is a two in the UV range. There is a two kind of the detector is available. One is the most common detector is the photodiode array detector. But this is simple, as which I already mentioned you. This is the simple machine, simple UV, which commonly used the pharmaceutical industry. This detector is used for already method. If the method is already set, then we are using this detector. If we are doing some R&D work, we are using a PDA detector instead of the UV detector.
It can also work in visible region.
This will work as invisible region because the UV range is up to 400
Yes.
nanometer or 350 as we, but it can be worked on visible. Anna, just tell us what is the sequence, how we will going to start this machine. What is computer? What first start with the computer or with the software with the hardware?
So first start this will initiate the all parts of the machine.
Except this detector. Okay? Except this detector, this button is only a start with the hardware of this system having sample compartment, column heater, pump, everything is start except the UV detector. UV detector we started because when we start UV detector, lamp is on, and as you know, the lamp has some light. If you are without working, you just start the lamp. It means lamp is going to decay and its life will decrease. So where we started UV detector when we are going to start the practical work or analytical work. Okay, now this light is blinking, means the UV detector is not ready yet. Initializing means the system is initializing, is still initializing. When the system is on and ready to work, ideal sign will appear here. And after this initializing, when initializing completed, we start the purging of the system. We are waiting because still hardware is initializing. Our mark is ideal machine, ideal. So now our machine is ready for dry purge. So Anna, just start the dry purge. Okay. System purge. Simple system preparation. Now system prepared, and we already mentioned 1 ml per minute and 25, 25, 25, 25. It means the all quaternary gradient pumps, pump A, pump B, pump C, pump D, with the equal ratio 0.25, 0.25, 0.25, 0.25. System per washing, and we remove the air bubbles. All the HPLCs take a lot of time, but only one HPLC, just for the information, log machine is your handling. If you are weighing, one time you can hold 2 columns here, and username and the password. When we give this username and password, and click the OK button, these 3 windows are there. Now, Sabah will explain how to create the method, to explain the software, how we can start it with the software. Our software is specifically designed for the waterless HPLC. So now,
according to the USP guidelines. Move to the next. Now you will select the items which you want to copy.
Now we are starting the practical demonstration of analytical HPLC.
We will log in with the user ID. Now sample. Number of samples, select the pump mode that is isocratic, and here we have the need to run click O. And click finish. As it is
Preparing the standard solution, you have a very good analytical balance, and analytical skill is more.
So in this presentation, I try to explain how the Waters HPLC is working, how the people are using analytical HPLC if you have some analytical machine, you have a detector, you have pumps, you have a heater. Sometimes heater is not an essential part, but if the temperature sensitive analysis, if you are required the temperature sensitive analysis, then at that time heater is necessary. You have an integrator. So, if this kind of hardware is available, then we can start our analysis or quantification of the unknown substance or known substance. Unknown substance again required some standards, but on this demonstration, we try to create the method. Always analytical HPLC, which is controlled by the software in every kind of the software. When we start the analysis, we have to mention the method, mobile phase, retention time, solvent need to be inject, how much quantity we are going to inject, and replicate of the sample, how many injection from the one vial or from the second vial. So it is all according to the standard procedure. So I try it to summarize.
More important, and when you weigh your material, you should confirm that material is 100% transferred into the volumetric flask, and the volumetric flask should be make up.
Here I'm trying to just for your understanding, I'm just trying. If we are making any standard solution for the analysis, the substance we are going to analyze is weigh accurately, transfer accurately in the volumetric flask, make up accurately volumetric flask, and visually observe there is no insoluble material is at the bottom or settle down at the volumetric flask.
According to the standard line, which is mentioned on the top of the volumetric flask. So the more important in analytical HPLC, not only software, not machine, is your handling. If you are weighing accurate analytical standard or your sample, then you can get the more precise results. Otherwise, no analytical HPLC will give you the correct result. The more important, again I am insisting you, the more important is the weighing.
So it means you are emphasizing on the primary step. The weighing is the most important step.
Not only weighing, weighing and the transfer of the weighing material into the volumetric flask and the makeup and solubility. For HPLC, if your substance or your sample or your standard is not solubilized in the mobile phase, it means all the exercise is useless. You have to show the sample which we are analyzing 100%, not 99%, 100% soluble in the mobile phase or solvent.
So this is the basic requirement of the HPLC. HPLC work on the basis of solubility. Gas chromatography work on the basis of thermal stability and volatility. So this is the basic difference between these two techniques. If the sample is volatile, thermally stable, we are going to analyze through gas chromatography. If the sample is high molecular weight and solubilized into the mobile phase, we are going to analyze or quantify or identify through HPLC. So this is the basic requirement for analytical HPLC. There is a long presentation which we will share with you on YouTube or Zoom, and we will send it to all the participants. Here we have some poll to see how many people are learning this presentation. Again, you have only 1 minute. Please fill it and submit. Okay, so most of the people are is responding well. Yes, the UV detector is the universal detector which we are using. Most of the analysis are using by a UV detector, and detection time is good. Most of the people are answered well. Okay, third one, 2. Okay, so I just want to show you the some other video.
Our method, and here we will untake these two according to the USP guidelines. Move to the next. Here we will select, as we are working on LC, so we will click LC. Move next. We need to run standards, so we will click at start of the sample set. We will run standards. we will start with the while number 1. So here you will give the first while here, then click next. Each standard while and other is for instrument. First we will click on instrument tab, and here we give some parameters like degasser. If you are working on isocratic mode, then there is no need to on this degasser mode. If you are working on gradient mode, then you need to turn it on. Right now we are working on isocratic mode, that's why we are
there is a question. Some participants ask about the duration and analysis time.
Yeah, it's from Shukurov Chaudhary.
Okay, so there is no fixed time for the analysis. It's depend on the length of the column, depend on your polarity of your mobile phase, and depends your working environment. So column heater and many things. For if you are in R&D phase, you when you are involved in the analysis, you just start with the maximum time and observe the peaks will appear or not. When peak will appear, no impurity, no ghost peak will appear in the second run, then we can reduce the time according to the retention time of the first run.
we click off. Now we will set the flow rate by clicking the tab flow. Here we will set the pressure limit, that is 4000 psi is the maximum limit and 0 is the lower limit. Now we will select the pump mode, that is isocratic. Now we will give the total flow rate, that is 1 ml per minute, and here we will select which pump we are going to use. As right now we are working on pump A, so we will give 100% composition of A. Move to the temperature tab. As in the method we don't need any temperature at the column or at sample compartment, so we will untick these two options. After setting these parameters, we will go to the UV detector. At UV detector, we will set the wavelength, that is 254 nanometer. We will tick on lamp and we will just save the method by giving the name Cephradine IM. IM is basically representing instrument method. We will give comment that we are performing analysis. We will set password and save the method. We will just minimize it. And here now we will select the same instrument method which we just prepared, Cephradine IM. Go to the next, and here we will give method the name Cephradine. Right now it is we are setting our method. So here instead of IN we will write NS, representing method set. Then we will finish it. Now at this window we will select the method, that is Cephradine MS. Go to the next. Now we will give the information of the sample. Number of sample 1, number of injections per vial we require 3 replicates for it. Injection volume which we are giving is 20 microliter. Click next. Here column information is required. If you are willing to write it, it's up to you. Go to the next, next. Here we have prefix for standard and sample. For standard we have STD and for sample we have UNK. Then we click next. Here the summary will be appeared, the method which we just prepared. Then click next. Cross this window. Here you will get the sample result which you just prepared. Now with the instrument method, select the method Cephradine IM and monitor it. As you click on monitor, so all the parameters which you set on this software will automatically move to the system.
The vial at a specific place in auto sampler. Run the sample Cephradine. Injection volume 10 microliter. 20 minutes or 25 minutes. It is monitoring and it is beyond the U0. You can auto zero from here. It has the provision in your software. You can auto zero the wavelength. And it is saturated. We can run our sequence like from this green button, highlighted button, like this. You can see the run over here. Now I am running the sequence. It is injecting, and you can hear the voice of auto sampler. It is taking the sample from your specific vial. After running our sample, you can observe the response of this HPLC in form of this peak. And what is the peak? Peak is the response.
So this is the shortest. We try to show you the shortest possible way to on analytical online. Is a difficult. We can demonstrate the real operation of the HPLC through this presentation, but we tried. And you can use this kind of the method for creating method and the shape of the peak, framing of the peak, and precautions during the analysis on especially on analytical side. So now my colleague is presenting a poll of quantification. Okay. So here there is a confusion here in question 2. There is about 38 and 48%. That one is correct. Is actually a graphical response of the detector and electronic response of the detector. Both are correct. So this is a right answer. So column 1 is use maintain the temperature of the column is the right answer. Not maintain the mobile phase. Maintain the temperature of sample. For maintenance of the temperature maintenance is a for that purpose column 1 is not using. For that purpose there is the chamber where the samples are kept. It is control. It is also temperature control, but that is not part of the column over. So the right answer is the maintenance of temperature of the column. Okay, so for this, I'm just finishing this presentation, and my colleague Dr. Yan will present the use of semi-preparative HPLC, and Dr. Atia will introduce Dr. Yan.
Thank you so much, Dr. Shakili, for a very informative presentation and discussion. So our next speaker is Dr. Yan Wang. She is Assistant Professor at HEJ Research Institute of Chemistry, International Center, Chemical and Biological Sciences. She got PhD in Pharmaceutical Chemistry from Institute of Metrica Medica, Chinese Academy of Medical Sciences, Peking, Union Medical College, China, in 2014. She has over 40 research publications in reputed international journals with total impact factor 125. Her current research interests include natural product chemistry, biotransformation, and metabolomics. So she is going to discuss about the preparative and semi-preparative HPLC and its optimum use. So Dr. Yan Wang, can you please take over?
Hello.
In this room.
Okay, you can take both mics.
Boss, can you hear me clearly?
Yan, where is your presentation?
Here.
All right. Then can we start?
Can you hear me clearly? Assalamu alaikum. And good morning, good afternoon. So let's start preparative HPLC part. So until now, we have learned a lot about analytical HPLC. Before we start preparative HPLC, we can think about one question. What's the difference between analytical and preparative HPLC? Here I have a video. Through this video, you can have a rough understanding You know, you have learned, now we are already going 1.5 of the workshop. So when we watch this video, you can have a rough idea about the whole process of the analytical HPLC. Then we are going to start what is preparative HPLC and what's the difference between these two. Maybe I should increase a little bit about the voice. I think it's a little low.
High-performance liquid chromatography is a technique in analytical chemistry used to separate, identify, and quantify each component in a mixture. As well as other forms of chromatography, in HPLC there is a mobile phase, which is forced by a pump to pass through the system. And there is a stationary phase called the column, which is located in an oven where the temperature can be controlled. The sample can be automatically injected into an HPLC system by the use of HPLC autosampling, or can be manually introduced into the injector using a syringe. There is also a detector attached to the HPLC system, which measures the analytes after its separation in the column. The pump forces the mobile phase through the column, and then the detector, under high pressures. In the HPLC system, a vacuum pump and a degasser are connected to the pump and used to remove dissolved gases from the solvents. The pump drives each solvent to the mixing chamber, where mixing takes place under higher pressures. HPLC analysis commonly uses isocratic or gradient elution. In isocratic mode, the mobile phase composition remains constant throughout the procedure. Whereas in gradient mode, the mobile phase composition is changed during the separation process. Sample introduction can be accomplished in various ways. The simplest method is to use an injection valve. In the load position, the high-pressure eluting solvent flows to the column directly. The loop is loaded at the atmospheric pressure from a syringe via the needle port. Excess sample exits the loop via vent port. After loading the sample, the valve is switched to the inject position. The flow delivered by the pump flows through the loop, forcing the sample ahead of it, flowing to the column. Then, the valve returns to the load position, and the mobile phase moves the sample through the column. The separation is based on differential partitioning of the sample components between the mobile and stationary phases. The component which has more affinity to the mobile phase, consequently less affinity to the stationary phase, travels faster and eluted out first. And the component which has more affinity to the stationary phase, consequently more interaction, travels slower and eluted later. This separation can be carried out according to which type of HPLC used. There are two main types of HPLC, reverse phase and normal phase. Reversed phase has a non-polar stationary phase and moderately polar mobile phase. One common stationary phase is a silica which has been modified by attaching a straight-chain alkyl group to its surface, such as the octadecyl group, C18, or the octyl group, C8. In this case, the more hydrophobic the analytes are, the more retained they will be on the stationary phase. The more polar they are, the more they will prefer the mobile phase. In normal phase chromatography, the stationary phase is polar and the mobile phase is nonpolar. This method separates analytes based on their affinity for a polar stationary surface, such as silica. In this case, the more polar the analytes are, the more retained they will be on the stationary phase. The more hydrophobic they are, the more they will prefer the mobile phase. As compounds elute from the column, they interact with the detector. Different types of detectors can be used, such as the UV-vis detector, which showing an absorption spectrum in the ultraviolet or visible region. For UV detection, a deuterium discharge lamp as a light source is used. And for components detection in visible region, a tungsten lamp is used. In UV vis detector we can also find entrance slit, lens, prism or diffraction grating, exit slit, flow cell, and detector for absorption measurements. Light from the lamp is shown onto the prism and dispersed according to wavelength. When the measurement is performed with a specific wavelength, the angle of the prism is adjusted so that the light of this wave can shine on the flow cell. As the compounds elute from the column, they enter the flow cell, where the bonding and non-bonding electrons of these compounds can absorb energy in the form of ultraviolet or visible light. The manner in which the final data is displayed is based on the computer and software. The number of peaks present can indicate how many components are in the mixture. Usually, the x-axis of the HPLC chromatogram shows the amount of time taken for the analytes to pass through the column and reach the detector. Typically, the y-axis, or the area of the peak, is a reflection of the amount of a specific analyte that's present.
Okay. So we will start preparative HPLC. I think from previous video, you have a rough idea about what is really going on in the machine, right? So for understanding of preparative HPLC, we have to think about the question, what's the difference? What's the difference between analytical and preparative HPLC? Why we have to explain these two separately, right? So for the difference, we can summarize this to several points. And you don't have to worry, don't read all these words. We will go through one by one to understand what's the difference. Number one is the difference about the target. Why we use analytical HPLC? Why we use preparative HPLC, right? What's the target? What's the target of this experiment? Or what's the purpose of this equipment? For analytical HPLC, it's used for quantification or identification of the compound. We want to analyze a sample. You know, before you do something, you have some question in your mind. Before we analyze a sample by analytical HPLC, what do you want? We want to confirm what is in the sample. This compound exists or not? What's the quantity of the sample, right? So this is the data we can get. We are not going to get the sample, but we want to know the information, right? For preparative HPLC, this is completely different. The story running behind the machine is very similar, but our target is very different. We use this machine to purify the compound. We want to prepare the sample, and finally, we want to get the pure compound. This is our target. So finally, we get the sample. This is a very big difference between these two. One thing, for analytical HPLC, we get the data, we get the information, we analyze the result, right? For preparative HPLC, we want to get the sample, we want to get the compound after the purification. And then for both HPLC, we may find this image. This is the peaks, this is a chromatogram we can observe in preparative HPLC, analytical HPLC both. But this is all we can get from analytical HPLC. And for preparative HPLC, you know the compound is running by the same way in the column. They isolate it, but then what we did, we collect the compound. The compounds, they are isolated with each other by the different polarity. Then we coming out the column one by one. From here, you can see the red compound first to come. Then we collect, and then we collect the blue one. By this way, we get the purified. We get this blue and this red compound separately. So this is the target. We get the compound. Then you can have a look, this too. If you are from like isolation background, or if anyway you have done similar experiments, then you can clearly see this is a column. And this is a normal column. And what's this? This is a preparative HPLC column, or we can say semi-preparative HPLC column. And this column is, we can see the color, very beautiful color. They are coming, this compound, yellow compound come, another yellow again come. This is a very beautiful column. And what is happening in this column is quite visible. What is happening in this preparative HPLC column is not visible, but the compound, they're coming by the same way. Only this column looks so advanced, so expensive, right, than this normal column. But as a matter of fact, this running so fast, the story happening in the column, it doesn't matter it's a normal column or this advanced column, the story is same because it's used for isolation. It's used to separate the sample. Okay, so the next difference, the difference is the direction of the sample. From analytical HPLC and preparative HPLC, they're quite different. From analytical HPLC, every time we only inject microliter, like 10 microliter, 5 microliter. That is a very tiny quantity. And that sample, we are not going to take it back from the waste. And for preparative HPLC, the sample will be collected, especially the peak will be collected. If we check this image of the whole, the whole thing of the HPLC, including every part, and here, if you check here, the solvent, they're going several steps. Finally, for analytical HPLC, it's going to the waste. And we are not going to reuse or recover. That is a very tiny quantity of a sample. And that solvents are also a mixture of different solvents. Sometimes we use buffer, a little bit acid. So we are not going to reuse, right? For preparative HPLC, this is the difference. We are not going to discard because our major target is to collect the compound separately. So the final step is not going to the waste. It's we go to a collector. If we don't have a collector, then we collect manually by the vials, by the tube, whatever. We collect the sample. This is also a difference. And the next difference, we can check these points together. All this about the size of the column, and the size of the particles in the column, and the flow of the equipment of this two different machines, right? If we talk about the size, for analytical HPLC, they have very standard size. Their column roughly a little bit similar, not exactly same, but they are very small column. For UPLC, HPLC, the column always small. The length from 150 mm to 250 mm. And after that, for preparative HPLC, they are different size. Why they're different size? Because we have different purpose. Like we are scientists, we are doing experiment. We are trying to purify the compound for research. We are not going to sell our compound for profit, right? So our scale is like a small scale of preparative HPLC. But there are some company, they purify the compound, they synthesize the compound, then they sell the compound for profit. So of course they need big scale, large scale, right? For those preparative HPLC, they have big size column, big size, powerful pump, big auto collector, everything big. So in lab, for research, for study, for us like scientists, mostly we actually using semi-preparative HPLC. The sample are not much. We have very precious sample, right? We have milligram sample. We don't have like kg compound to purify. This is normally we are using actually semi-preparative HPLC. This is the one we are using usually. Okay, if we talk about the size, the column, we can see directly how the size are different. This is the small one, all these are analytical HPLC column. For this very tiny one is for UPLC. It has higher pressure, and this you can see the size also smaller, right? And this one is for HPLC, and this is 250 ml. And this is for semi-preparative HPLC. This is normal size. And this is the guard column for protection. Before this one, this small one will be protect. And then from here, you can see the preparative HPLC. This is actually bigger, right? Then what's this? Oh God, this is like huge, big column. And here, you know, the right one, this is like the industry scale in the factory. And there's someone, because it's too big, so someone they have to climb in from here and go here and have to work on this part. Like there's a 4 or 5 person can stand on this plate. You can imagine how it's big. Here is some different size in between. From this most tiny one and the biggest one, you can feel the difference, right? So this equipment can have dramatic difference, significantly different size. Now the question, if we have very different like HPLC, and for this advanced machine, the column is this size, and for this in the factory, the size are huge. Can we run the same flow? Can we use the same flow to run this column? Of course, the flow should be different. If you run this column, like after 30 minutes, you collect the peak. If you use same flow to run this column, then you will have to go, maybe you go to take lunch, then you pray, then you sleep, and then maybe you go for travel and visit some friends, then you come back to collect your peak. Because this is too big, it's not possible. So for this flow, it's very fast. Only this we can work on this. So this size difference is make big sense for the difference of the analytical and preparative HPLC, right? So this is the column, big difference. And the next difference, number 6 and number 7 points, is about the mobile phase. And also about the sample, the solubility of the sample. For, you know, for analytical HPLC, if the sample is not fully dissolved in the solvent, if we just want to have a look, then you can just filter the sample and you can check the soluble part, you can get some idea. But if you want to purify the sample, you want to purify a mixture, and you are only able to dissolve 10% of the sample, how can you purify the sample, right? So this sample should be dissolved properly in the mobile phase. If the question is that if your sample really you are not able to dissolve, then but you want to inject, then what will happen? You know, if a liquid you have made lots of efforts to dissolve the sample by solidation, by heating, by lots of efforts, especially by increase the temperature, then when the sample in the column is cooled down, when it's cooled down, the solid particle they start coming, then your column will be blocked. When your column is blocked, then the pressure will increase. And when your compound become a solid, it will be not able to absorb in this, either silicon or C18, whatever. If it's not able to absorb inside, then of course the separation will not happen. So solubility is important before purify your compound. And then, you know, for the big scale, large scale of the preparative HPLC, they are using like liters of solvent, not liters. like maybe like 10 liter, 20 liter, several like 100 liter per day. And this HPLC grade solvent, as Dr. Shaki already explained a lot, these are HPLC grade solvent. Those are very expensive solvent, and there's a huge quantity will be used. So it's better if we can recover the solvent for the large quantity, and we can adjust by the density, because every pure solvent, they have a certain density. And if we use the same ratio, then we get the density, we can compare, then we can prepare exactly the same ratio. Because of quantity issue, it's a huge quantity of solvent, right? So this is also difference between HPLC, analytical HPLC and preparative HPLC. So I think until now, you may have some idea about the difference, right? Now we will pull our question and you will try to answer about the difference. So you have 1 minute to answer this question. Okay, I think maybe my question is designed a little difficult. So the first, what's the purpose of preparative HPLC? As we said, for analytical HPLC, we're used to analyze the sample, right? For preparative HPLC, we use it to purify the sample. So it's used for purification of compounds. And the number 2 question, which one is run? I think I should not design something like this. You have to a little bit maybe like confused. So preparative HPLC have bigger column, right? This is fine. Preparative HPLC column have bigger particles. Particles also a little bigger, because analytical HPLC, they have little, like very delicate column with small size of particles. And preparative HPLC and analytical HPLC need same quantity of solvent. As we saw, the like very big, huge, big column for preparative HPLC, industry scale, that one is need large quantity of solvent. So this is run, right? And the last one, preparative HPLC have higher flow. Yeah, this is for sure. It's need higher flow. And the last question, if the sample cannot be dissolved in the mobile phase, what will happen? Which answer is run. If the sample cannot dissolve, then there's no good separation, then the pressure may be high, and maybe the column also will be blocked. And the detector remains same. It doesn't matter. It's what is going on in the column, whatever coming from the column, the detector will detect. Okay, thank you very much for your answering the polling. I will close this. Okay, now we start optimize use of preparative HPLC. How we are going to use, how we're going to perform preparative HPLC, right? So here we are going to start a procedure, the general scheme of using preparative HPLC. We want to purify the compound by preparative HPLC. Before that, you know what you are going to do. You're going to purify the sample and which sample you're going to purify. Which sample can be purified? Which sample need HPLC to purify, right? For the sample, the normal way in lab is to take in TLC or analyze by analytical HPLC. You know, for this, we have to use analytical HPLC. We are not going to inject the sample without any information. If you have no idea about sample, how can you inject in the preparative HPLC? We have to analyze clearly, then we decide what to do. Then we will decide we have to use normal phase or reverse phase. If we decide to use reverse phase, so what's the percentage? We are going to use Meissner water system or acetonitrile water system. If we decide to Meissner water system, how many percent of Meissner should we use? For all of this, we have to confirm before you are going to conduct your experiment. All these are most important. Which system is the best system to purify the compound, right? Then you are very confident everything is ready. You are going to really use preparative HPLC. Before that, you will have the solvent, HPLC grade solvent. Then you will prepare your solvent system. And then as we go to the machine part, right? We will go to the HPLC, then we work on this machine. Then we have the understanding about the sample. You know from your sample, like, you know, you have two compounds, you have to like separate these two compounds, then you will get the two peaks, you will collect these two peaks separately. You will collect the target compound, right? And then after you're getting the sample, you have to check again what you have achieved. The compound was successfully purified or not. You have to analyze again. And after that, you will do necessary analysis as you wish. And of course, you are working in different field, it will be quite different. We will start, of course, again, one by one, step by step, right? So the first thing is to like decide the sample, what you are going to do. Yesterday, there's I'm sorry, I forget the name. She's asking, can she inject the crude extract to the preparative HPLC to purify the compound? You know, the crude extract, if I make a circle here, you will see this. When I saw this TLC from my student, I just suddenly remember a very popular Chinese food. This is made a kind of a fruit. And children always like, this compound on the TLC is just like this foot, one by one, very organized. So yesterday, I think ago, she asked, like, can we inject? If we can inject this sample to preparative HPLC, then we collect the compound one by one. Then from your crude, you like get 20 compounds in one go. Is it possible? I would say it's kind of not possible. Why it's not possible? Because in your crude, you have huge amounts of compound. It doesn't matter from where. If you work on plants or microorganisms, if you get a crude, in the crude it's always many compounds. From the plant, one plant maybe have 100 compounds, maybe more than that, much more than that. If you have For the semi-preparative HPLC, every time you inject like 20 milligram, maximum 30 milligram. So for every compound, what's the quantity? The quantity of every compound is less than 1 milligram. When you inject, there are so many peaks that are coming. Can you get the pure compound? Because everyone has so less quantity and the peaks are not isolated at all. So in this case, it's not possible, just like the life is so easy, you just enjoy the research and inject the crude and get the pure compound. Research is so simple, a piece of cake. It's not so simple. Only when the sample is quite simple, have very few compounds, and the purity is already quite good. And you can see the condition of the sample looks clean. If the condition of the sample looks very dirty and there are so many impurities inside, you can go ahead to inject, but it's very difficult to get the pure compound because of complex sample. You know, preparative HPLC is very powerful. It doesn't mean it can do everything, right? Always, every technique, there's some limit. Okay, see this sample. I have circled this sample. They have like 2-3 spots and very clear spot, and the condition of sample are quite clean. And you have like quantity. If you have like, I only have 1 milligram of the sample, then is it possible to inject and get the pure compound? The possibility of very little. If you say, oh, this sample is very clean, and I have only 2 spots, and I have 1 gram. If you have 1 gram, why you bother yourself go to preparative HPLC? Because for preparative HPLC, let's say lab scale semi-preparative HPLC, the column only can load 20 to 30 milligram. If you have 1 gram sample, and how many days you will spend on this machine to inject the same sample? So for the 1 month, you only inject the same sample. It really makes sense or not? How much solvent will be wasted, right? So different quantity and different condition of the sample. Always you should design different methods. This is very important, not only for preparative HPLC, I think for every research work. And the second step is to, of course, decide the solvent system. For this, it's the same TLC you have seen from the previous slides. From this TLC, I didn't write the system, whatever the system. Maybe it's hexane at a state, maybe it's DCM methanol. This is a normal phase HPLC system. You can decide the system by the TLC before you go to inject your sample. And for reverse, if very normally used, you can confirm the system by analytical HPLC. And you also can use reverse TLC. Same C18, if you're going to use C18 reverse column, you can use C18 TLC to check, right? If you're going to use C18 reverse column and you just use a C8 analytical column to analyze them, this is not, it's not at all like happen like that. Always use the same column, or we can say the same material on the TLC or in the column to analyze your sample. And if you have like IF value, like around 0.4 to 0.5, this number is not pretty fixed. You know, we always need to have a logic about the correlation between the TLC and the column. There's a plenty number of column, and the column, they have difference. And you need to have a logic. If you take TLC, if you use the same column, what's the best IF value should select? This correlation you need to figure out. If you use an analytical column and all the time you use the same column to decide the system for preparative HPLC, then you also need to have the same idea about if you use same ratio of the methanol water, what's the retention time is the best system for preparative HPLC. Because these are very typical conditions for very different column. So always you need to have an idea how to confirm from your column, right? Okay, so here is lots of HPLC solvent. You know, when you design your system, you have to prepare your system. And you have to remove the bubbles from solution. And then you can settle down the system before the machine is ready. And this is like a normal procedure, right? And now we are going to the machine part. Okay, this is a very old preparative HPLC, but you don't have to mind, it's very old. It's functional well. It doesn't matter it's old or very much advanced. You know, our target is to purify the compound, and it doesn't matter it's old or new, we can purify the compound, then it's good, it's functional. So when we switch on the machine, here I have the video. You can have a look. You know, there are so many different HPLC from many companies. And of course, every company, they have different like software, and they have different looking, and they have different way to switch on. Here we need to understand the normal procedure. And when you switch on the machine, then you have to switch on the pump. It doesn't matter this HPLC is produced like by which country, which company. You have to switch on the machine, you have to switch on the pump, because the pump is a power source. From here, the solvent is able to run, right? So here the system, the machine is on, and the pump is on, and then the detector is on. For this very old HPLC, there's a two detector. One is UV, one is IR. As you have learned from Dr. Shaki and Dr. Jianhua, now you already have idea about the different part, right? So after this, okay, the previous slide is for switch on the machine, now switch on the pump. When the pump is on, we have to purge. You know, this is the same thing. You have to purge for analytical HPLC as well, to remove the bubbles, to remove, like, to make sure the system is stable. And here, the video is on. So when we purge, means the solvent will be directly go from the solvent bottle to the waste before column. The solvent, okay, now this pump is on. If we switch on this button, if we rotate this to this direction, then the solvent, we will directly see this noise of the purging. It's moving. The pump is work like we saw in the previous video. You know, by this way, the bubbles from the solvent and the bubbles in the pump, they can be removed. And though they will go to the waste. This from here, they will not go to the column. The column is quite safe. Okay, now we will set the flow and set the maximum pressure. You know, for we have an idea for your machine, you know, what's the best flow. Like for semi-preparative HPLC, usually like 4-5 ml per minute. This is a normal flow, right? And why we have to set the maximum pressure? Sometimes, you know, if something happens, for example, if your sample is not soluble, but you have like heat a lot, make it soluble, then it's like the particles, they're going, or they appear in the column, then your column is getting blocked. Then the pressure will suddenly become huge big. And there's a certain number. If we set this number, then the machine will automatically stop. We will not allow the pressure go to extremely high than a certain value. You know, it's quite dangerous. The columns start linking, and the tube was tight and getting loose also start linking. So we have to set a number for protection. This is why. And we have to set the detector. You know, for UV detector, if we have like advanced like PDA system or DAD system, the name is different in different company actually. we can check the full wavelength of UV. And for this old machine, we can set only one wavelength. If you have a clear knowledge about your sample through analytical HPLC, and you know the maximum absorption in the UV, you know like 220 is the best wavelength. We can observe the maximum size of the peak. Then you should set that wavelength. And here we can set the sensitivity. The sensitivity of the machine is decide the size of the peak. If we set a very high sensitivity, then the peaks will become very big. It's more like visible, right? And for another part of the detector is II detector. For that is for general compound, right? It's general detector, which can detect different kinds of compound. If your sample is UV negative, right? If your compound, the structure, you have idea, if you are working on synthesis and you know there's no any conjugation system, and then from UV, you only can observe very little peak or like you cannot absorb the peak at all, then this II detector is very important, right? So this number need to set. And then after this, yeah, this here is RI detector. And here also you can set up the sensitivity, right? And you can purge, means balance a number. If you are washing and the number, when you balance the column, before you inject the sample, this number should go to 0, right? You don't want to see any number before you inject sample. It should be balanced. Now it's question. If you have switched on the machine, you have purged your solvent, and you have set up the detector, can you inject your sample now? Can you just feel everything ready? Why I cannot inject my sample? Okay, the question is, your column is clean or not? And if your column is clean, you have already balanced your column or not? In case, if like before you, someone has used a machine, someone has already used very polar mobile phase, it didn't fit your sample at all. If you directly inject your sample and then you are using your own mobile phase, since you know the column is not empty, the column is always already full of the solvent. And if this solvent is not the same solvent you are going to use, then for sure it will disturb your purification process, right? So it's very important. Before you inject the sample, you have to make sure use the stronger solvent system to wash the column properly. And then balance by your own mobile phase, which you decide to run your sample. Balance for a certain time. If we are like all use the same size, semi-preparative HPLC size, then like at least 20 to 30 minutes balance, right? Make sure you know the detector giving you a very stable line. And it doesn't matter which solvent, which system you are using, normal or reverse. Always use the stronger system, right? For hexene at state, hexene acetone, or chloroform methanol, right? So methanol or hexene or at state acetone, these are the stronger solvent. These are the polar solvent. So you have to use the polar one to wash. If you use 100% hexane, it doesn't make any sense. It's not wash at all. If you're using reverse phase, then methanol and acetonitrile, these are the nonpolar, and this is reverse. The nonpolar solvent, these are more powerful, more stronger solvent to wash everything. Make sure the column is clean before you purify your sample, right? And then balance by your own mobile phase. Okay, now since we have already washed and we have already balanced and looks like everything's ready, now we are going to like prepare the sample. You know, one thing we have mentioned before, we have to dissolve the sample properly by your mobile phase. And this is to make sure we are not going to absorb very different solvent peak. If you're using like reverse phase, if you're using like methanol water system, like for example, 50% of methanol, then you dissolve your sample by methanol. What will happen? You know, it's not like a disaster will happen. Disaster will not happen, but you will observe a very big methanol peak. Whenever you observe, or whenever you inject a different solvent, different with the mobile phase, then you can observe the solvent peak with huge. And the detector may be not balanced well, especially for RI detector. So this will disturb your sample purification process. Make sure this is the best situation. Make sure the mobile phase can dissolve the sample properly. And here, you know, for every injection, we have already understood before there's a some injection loop, and there's a proper volume of the sample of the injection loop. So if you have a sample and you try to dissolve, like I just like to dissolve by like 10 ml. If you're going to inject your sample, if your sample loop is only 3 ml, and you're just happy to dissolve by much more than this volume, then you have to inject like multiple times, right? So if the quantity of the sample is quite acceptable for one injection, then you should make sure to use the volume of the loop. If you have a 3 ml loop, then you use 3 ml to dissolve your sample. This is the best option. If you say like the quantity is a little bit too much, you have to inject 2 times. Then you can like use double volume, right? Double volume to dissolve. Then you inject like 2 times. You need to have a clear idea about the volume. So here, this is my PhD student, Mr. Amir. And if you have any question, he's also online because he's also joined me to prepare the presentation. So he will answer related question, okay? And he's like soaking the proper volume of the mobile phase and to dissolve the sample. And then now the sample is like, sample should be dissolved properly with a clear solution, right? And he's showing this volume 3 ml because the injection loop is 3 ml. And then we have to filter the sample. Sometimes there's some dust or some particles, something just a drop to your sample. You have to make sure we have to inject a clear solution. By this way, the column can maintain properly. If you just inject whatever you want and there's lots of dirty particles, then your column will finish very soon. We have to protect the column properly, right? So here, we are going to show how to filter the sample. This is the filter. This is how it looks. And this filter, there's a different filter, some for like organic solvent with different color, some for like for water. They are different. So when you use the filter, make sure you are using the correct one. If like you are using the filter for water to filter your organic solvent, then the filter will immediately like become like damaged, and your sample is not filtered at all. Okay, it's showing this. This is an injection. This is a manual one. You know, for preparative HPLC, the injection is manual, not auto sampler, not by the automatic injection. So here is doing filter the sample. Yeah, the sample is filtered properly. Then we can get the clear solution of the sample. Now, okay, from here, he will filter the sample. Okay, this is a clean one. You know, we are going to filter sample, we get a very clean solution. So we have to use a very clean vial or tube, whatever, to like collect the clear solution. It has to like wear a hand, wear the filter on the injection. And here, if we go to the vial and we a little bit gently press the injection, not very hard, right? Gently and softly, so the solution is coming. If you have a sample and it's not dissolved properly or it's very dirty, lots of dust, lots of particles, then if the pressure is too high, then it's maybe start leaking and the sample will getting wasted. So should be careful when you use this filter. Okay, now we get very clear sample solution. Now let's see. This is, we have already seen the video. It's very clearly to see this sample loop, how it's work. Now this, here we can clearly see this is like different circles. This is the injection loop. When you inject the sample, you know, here is 1, 2, 3, 4, 5, 6. This is 6, right? From the video, we can see clearly how it's work. When we inject the sample that we keep in this tube are very slim, and they're different. So see, 3 ml. So the maximum volume of this loop is 3 ml. When you inject, if it's more than 3 ml, then it should go to outside. And we always have a vial or a small flask, whatever, to collect. Then collect, if your sample is a little too much, you can like take it back. Maximum only 3 ml is that we keep here. Then when we switch on the injection, then it will go from this tube to the column. That is the next step. Okay. Here we are going to inject. We have already filtered and I will show you the loop. And of course the loop is separate. I'm not going to like take out the loop from this machine. It's a separate loop, just want to show you how it's look. And here we are going to inject the sample. You know, we have to make sure the bubble should be removed from this injection. If you have the experience, you are injected in the hospital, you know, the doctor, they should work very carefully, or the bubbles should completely removed, otherwise it's dangerous. So now he's inject, and then here he's going to move this to the load mode, and then gently and softly push. Now the sample is going to the loop, right? Now they are going, and he prepares 3 ml. All these 3 ml, they will go and they will just remain in the loop. Okay, it's about to finish. And now, okay, still pushing. Okay, now he's going to move. Now this mode changed. Now this loop is connected with the column. And then the sample that we go from the loop to the column, right? Okay, since the column is running and after some time, this is a very old, it's by printing, not by computer, but this is fine. You know, the story is exactly same. You know, we inject from here and the peak, there's a little peak. This peak may be the solvent or maybe little impurity, they become. Now if you see the needle start drawing the peak. The compound start coming, right? And why there's 2 needles? Because we have 2 detectors. One is UV, one is RI, right? And for UV, we can see the like running so fast. But for II, it starts slowly and gradually. Why? Because the sensitivity of the 2 detector for this compound is different. It's UV positive at this wavelength. The UV can give a big value. And usually the RI detector, they are not that much sensitive like UV. But still see, we can see a peak. So both of the detectors, they have given us a beautiful peak. And meanwhile, You know, we are not only watching the beautiful peak, we have to collect the peak because the peaks are coming. Now, if you are not going to collect, then you completely just lose the sample. You have to collect because this is your target. Why we are using preparative HPLC? Because we want to collect the pure compound from a mixture. So you have to collect. Why? Meanwhile, you know, when the peak already you feel it's ready to come, before the peak, you should already get ready. If the peak already like half finished, then you already lose half of the quantity, right? So always collect the peak, and when the peak like kind of becomes slow, kind of becomes stable, then you have to change the vial because the compound changed, right? Okay, here actually this machine is recycling, recycle HPLC. What is recycle? Recycle means when this compound come to the column, we can like change the fluid, we can change the way this compound can go back to the column and get purified second time. If the first time, like you are not happy, we just see some little impurity, they could just come together. If you do the recycle, then they will go back to the column and get the second time purification. By this way, you can like purify the compound in one go. For this, you need to have a clear understanding about your sample, or you can inject a small amount just to check the profile, just to check the possibility, the situation, then decide you are going to recycle or not, right? Okay, since we have explained a very old machine, so now I will use few minutes to explain an advanced machine. Okay, let's see this one. This one looks much more advanced than the previous one, right? So what's the difference? Sorry, what's the difference between this advanced machine and the old one? Okay, here we can see the difference. You know, from the previous old machine, there's only one bottle of solvent. We have prepared the solvent, whatever is required, like 80% of micellar water. We have already prepared 80%, exactly 80% of micellar water, a mixture of the two solvents. But here we can see 2 bottles. And actually it can use for 4 bottles. And this is design is exactly same like analytical HPLC, right? We don't have to bother ourselves to prepare the solvent. The machine itself we prepare for you is advanced. You know, this is the advanced part. And then the second part is a control panel here. Now we have a computer instead of the painting needle. We have a computer, we have a screen. And from this computer, and this is touching screen. We can touch it, then we can set the method. Amazing, right? And here we can monitor, we can see the peaks. And here, the next difference is the auto collector. You know, everything, like all these 3 differences, they were done manually, now they become automatic. All the development of the equipment, they are just all the time try to do everything automatic, right? Like from manual car to automatic car, same story. And here we can collect the sample automatically. And you can see here the tube, they have collect the peak. And according to the detector gives the value of the peak. And according to the value, they will change the tube and start collecting another peak. This is automatic collecting your peaks. Everything automatic, right? And here, this is a control panel. This is the screen of this computer. From here, we can see the solvent. We can design the method. right? And this is the method program. And from here, we can set the pressure, the flow, and we can set like the detector UV wavelengths. From here, we can set 5 UV wavelengths because it's full range UV detector, and everything like looks advanced and automatic. And then here I have recorded a small video. You know, when we use the old machine, we collect the sample manually. When we just see by our eyes, when the peak come, then we collect. But for this machine, it's we collect automatically. Here the peaks are coming. We are not able to see clearly. You know, from here we can see, here is the drops. The drops are from the column. And here, these 2 tubes, they are very tall. So you can see the other tubes, they are a little bit short. So you are not able to see, but there's many tubes organized here. And the drops from the column, they are keep dropping to this tube. This tube is automatically collecting. And here, if we see the new peak start coming, this auto collector is we automatically go to another tube. So the machine has done everything for you. This is automatic preparative HPLC. For the previous old one and this advanced one, they have same target. Only the old one, we have to do something manually, and the advanced version of the preparative HPLC, something become easy. Like your work is reduced, but your target and your achievement, your purified sample, all these are same. When we purify the sample, we get the pure compound. We are very happy. Then you have to confirm the purity, right? If you get a pure compound successfully, then you can go to some analysis. And this is will depend on your whatever you are doing, right? Okay, since we have done this part, so now I will bring some question for you to answer. So you have 1 minute to answer these questions. Okay, I think I used to design the question like this since it's a little difficult for you. So number one, which part of the equipment is not included in preparative HPLC? This is auto sampler. Auto sampler is injects the sample automatically, and this is not included in the preparative HPLC because we have to inject sample manually, right? So the number 2 question, which one is wrong, right? This is a different logic to ask the question. You know, the proper solvent system is always very important for the use of preparative HPLC. And the sample for preparative HPLC can be dissolved in any solvent. Is this correct? You know, we have to try to dissolve your sample by your mobile phase. For this, we can make sure the sample is running properly, right? So this is wrong. And the last question, which one is not the difference between the old and new preparative HPLC? You know, we have seen there's quite advanced machine and the old machine. The injection loop is kind of remain same, right? And the control panel and the monitors quite different because advanced one, they have the computer, right? And the conductor is also quite different. we can collect the sample automatically by the advanced machine. And the pump, you know the pump, they look same. But the difference is for the new machine, we can use the two solvent from the two pathway directly. And for the old machine, we have to prepare by ourselves. This is the difference. Okay. So we have done the introduction of the preparative HPLC, and we know it's very different. Preparative HPLC is used to purify your compound, not to analyze your compound. And we have done the different steps of the preparative HPLC, so you can have a clear idea about what to do, right? If you have further confusions, you can contact me or my student for further discussion. Okay, lastly, finally, I will bring my thanks to respected Professor Adar Rahman, Professor Iqbal Jodri, Professor Fazana, Dr. Adia, Dr. Shaki, and Dr. Jianhua. Okay, thank you very much. So you can ask me questions through my email, and I wish you have learned something. Thank you very much for your attention. Now we will have a last polling. So I would request you kindly answer the coming polling. So we want to understand what you have learned, or are you satisfied? Do you have further suggestions to improve the quality of our workshop? Thank you. Please spend 1 minute to complete this question. Okay, thank you very much for filling up this polling result. Thank you very much for your positive response. And we also will try to improve further. Thank you very much.
Bismillahirrahmanirrahim. Assalamu alaikum. And thank you so much, Dr. Yan, for a very informative presentation. And now we are the concluding part, and I would request Aziz for the recitation of the Holy Quran.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم والتين والزيتون وطور سينين وهذا البلد الأمين لقد خلقنا الإنسان في أحسن تقويم ثم رددناه أسفل سافلين إلا الذين آمنوا وعملوا الصالحات فلهم أجر غير ممنون فما يكذبك بعد بالدين أليس الله بأحكم الحاكمين صدق الله العظيم.
Jazakallah. Now we have our respected teacher and Coordinator General Comstech, Professor Dr. Iqbal Chaudhary. I would request sir for the concluding remarks.
Auzubillahi minash shaitanir rajeem. Bismillahir rahmanir rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. My colleagues in Islamabad, my colleague in Karachi, International Center for Chemical and Biological Sciences, very distinguished speakers who conducted this workshop very nicely. And I'm sure that this has been immensely popular, as I can see that a very large number of participants from different countries attending and benefiting from this workshop. As I mentioned during my opening statement, that HPLC is one of the most important techniques used in a whole range of different fields, from environmental sciences to food science, from analytical sciences to chemistry, biological sciences. And therefore, developing understanding and appreciation of HPLC is extremely important for scientists. It doesn't really matter whether you have a background of chemistry or biochemistry, you still need to have skill in HPLC, even if you need to work in the field of environmental sciences, archaeology, food science, industries, and different kinds of. So HPLC is certainly a very important one, and I'm extremely pleased that this is used, this is selected as a topic of a skill development workshop. I'm also very happy that the modern technologies have been used. So we have been exposed to discussion group. We have been asked to fill various performers in real time. And this gave the speakers understanding of the status of knowledge which has been imparted through this workshop. People who have delivered this lecture, both from Pakistan and from China, they are real practitioners of HPLC. They have been using HPLC for quite some time. So it's not a bookish knowledge. It's not something which they have presented you from manual, but they are the one who actually been using this technique for their own research, for their own analytical studies. So the knowledge which you have gained is way above which you can learn from any book on HPLC. It is a real-time understanding of a topic of extremely complex nature. Because as I mentioned during my opening statement, HPLC can be used in a very benign manner, and you still don't know the troubleshooting of that, and you don't know how to make best out of this machine. So these practitioners have actually provided you the best of their own understanding. I hope that you have benefited from this workshop. This is the key objective of Comstech effort. Our focus has been largely on capacity building, because we feel that without capacity building, there is absolutely no good quality science and technology research can be initiated or industrial work can be initiated. So the key element of Comstech focus is on developing skills and capacity, and such workshops play extremely important role. So let me congratulate my colleagues who have put together a very nice workshop. First from Comstech, my colleague Khazima Muazzam, she has been absolutely wonderful in organizing lots of these events with diligence and care. Dr. Atiyatul Wahab, my colleague, she has been organizing these events for Comstech with the with the motivation of contributing towards science and technology. My colleague, Dr. Shakil Ahmed, who is a leading analytical scientist, and he has presented a very good lecture yesterday. I'm sure that you have learned from him because he has used HPLC more than anyone else in the country, because he handles literally thousands of compounds of a variety of different natures. Some of them are extremely complex and challenging. Dr. Yan Wang, he is an amazing speaker and a very good scientist, very focused, and someone who has actually, someone who has used HPLC in her work both in China and in Pakistan. And our very dear friend, Professor Dr. Jin Hua from Hunan, who is also very closely associated with the International Center for Chemical and Biological Sciences. He has been using HPLC for research and analytical work. So all of them have worked extremely hard to present to you along with their teams, because there are many people who have been behind this whole successful effort. It's very difficult to name all of them. But I see Dr. Amir, I see Dr. Muniza, and many more. They all have been extremely diligent in putting together a very good program for you. This is, as I mentioned, one of many. So please do send your feedback and do let us know whether you would like this series of workshop on analytical techniques to continue. If you do feel that, please send your feedback and also tell us what is the effective way of delivering that. Thank you very much.
Thank you, sir. With the sir remarks, I would also like to request that we have a feedback doodle form, which we have already up in the Zoom and also on the YouTube. And it's really important. We want to have your feedback about the workshop so that we can improve next time. And also, we would like to have your correct name and email address for the certificate. So kindly submit this doodle form, and thank you so much.
Thank you.